Now that we have made our first sketch, we can see that we also made a previous plane 2. So here in the model tab, you can see where my cursor is. I'm in the model tab, and we have this option called create solid and create surface. So we can start by clicking on the extrude option, and here my sketch is selected, so it came in by default. But if it's not the case, you can click on this asterisk button. When you click on this asterisk button in Design X, it will unselect anything that you have selected in there. So if I have this sketch selected this way, if I click select none, it would remove all the selections from the current selection. So now you can click here on sketch 1, and you can see that you get a particular blue arrow. So you can drag that blue arrow and drop it to wherever you see fit. So you can either add it here, or you can add a particular number. This is exactly like in CAD tools. You can add a number here, say 50, and it will form an offset, and it will create a solid. So the moment you click OK here, it is going to create a particular solid. Then you can see that your first command extrude has come in the model tree, and in the bottom, in the finished portion, you see something called solid bodies here, where you see my cursor. And if you expand that, you'll see that there's a body called extrude 1. So you can hide and you can show this particular extrude. So you can hide this body and you don't see the CAD file that you made. And here when you click extrude 1, it shows this particular body to you. Now that we have our first solid made, we can check the accuracy of the solid by clicking the accuracy analyzer or the deviation plotter. So here you see in the screen there is a colored cube where my cursor is. So if you click on it, the body is basically going to show you a colored heat plot. And there is a color scale over here on the side, which you can change as per your needs. So here, wherever it's green, it's within 0.1 millimeter. So you can change it by double clicking. You can change it to, let us say, 0.15 millimeters. And wherever the deviation is within 0.15 millimeters, it would show in a green color. And the areas where you have positive deviation, where the CAD is above the scan, you'll see them highlighted in a yellow to red color. And in areas where you have a negative deviation, it would show the deviation in a bluish coloration. So here I have a deviation of minus 0.8135. So when you hover over a particular point, the software will show the value of the deviation between the CAD and the scan at that particular point. So I keep my mouse here, it's 0.0476 mm in the negative direction. I move it to a more bluer spot like this, it's more deviating, so it's 0.8148 millimeters. Now, one thing we can also see is that we simply added a dimension for the extrude instead of extruding it up to this plane. So if you want to extrude up to a plane, you can right click, and instead of making another extrusion, you can say edit. So when you edit, you come to the extrude options again. You have the sketch loop that you picked, and here in the method, we are in the blind method. So instead of blind, you have all these options. You have up to vertex, up to region, up to surface, up to body, and midplane. So you can say up to surface since we made a plane. So you can say up to surface. And when you click on up to surface, it will ask you, okay, so you clicked up to surface method. Where do you want me to extrude up to? So you can choose a plane or a face. So here you can hover your mouse over plane 2, and when you click it, it will show plane 2 here. And when you show plane 2, it will extrude up until plane 2, and you can say OK. Now you can see that in your accuracy analyzer, it's very green here because we earlier created that particular plane and we fit the geometry of the extrude up to that particular plane. So here I can turn off my accuracy analyzer and my heat map would disappear. So I click here, the heat map is gone, and we have made the first extrude of our particular body. Now we can hide our solid and our mesh. So I hide my mesh, I have my solid here. I can also hide my reference planes by hiding plane 2. Now I'm going to hide my solid and I'm going to show my mesh, and I can see that there is a cutout here which we are missing in our original solid. Our solid looks flat here. So I'm going to hide my solid again. Now the option that we need to do is to make this cutout so that we are closer to the scan. So in order to do this, keep your selection mode in the Smart Selector mode and select this particular area. So click and hold your left mouse button and now move it to increase your selection. So here we got a good amount of points. Now if we want to do the same here and add these sets of points, hold Shift on your keyboard and make a single click and increase your selection. Please hold Shift all the time. And now when you made your selection, you can see that you have selected the poly faces here, the triangles here, and the triangles here. Now we need to make a best fit plane. So you can go to the Model tab, and here you would see the Plane tool. So you can click on the Plane tool, and in the method, you can keep the fitting type to best fit. You can change it from max bound to best fit, and you can remove any axis constraints and then say OK. So now you have best fit a plane 4. And we're going to follow the same process. So we need to make the cutout. So we need to see a clear preview of this particular edge that you can see on the screen where my cursor is. So to do that, we can go to the Sketch tab and we can go to the Mesh Sketch option. So we are going to essentially trace out a cross section. So we can click on Mesh Sketch. Now when you click on Mesh Sketch, since plane 4 was already selected, it's showing that preview. But if it's not the case, you can unselect it here and then select plane 4 from your model tree or from the screen. And we can see that it's generating a turquoise colored preview or the cross section, but we can see that it's not a good cross section. For example, in this area, I'm getting a jagged line here instead of this shape. So I can either increase the offset here, or I can hover my mouse over this blue arrow, click and hold that arrow and move it up. Now when I move it up a bit, I see that I get this particular trace clearly, and I get the same on the opposite side, on this side too. So I see this feature very nicely, and I see the same here. So this preview looks good, and you can say, okay. Now, like in the previous case, it has provided that pink polyline trace for us. You can hide your mesh, and you can start making your sketch. So here, you can go into the line tool. So you can click on the line tool in the sketch and double click to get a line. Double click here again, hover over this segment, double click. And in case the double clicking does not work, you can come to the drag box mode, make a drag box, and give a check mark here. Either methods would work. And following this, you can add a 3-point arc here. So double click on that arc, double click on this arc here, and it will trace a best fit arc across your selection. Now we can start adding our constraints. We can say select both of these, this line and this arc, and we can go here to constraints and make them tangential by clicking on tangent here and say OK. And you can see that it has made the tangential constraint. We're going to do the process again. So select the two segments that you need to apply the constraints to by clicking on segment 1, Control or Shift clicking on segment 2. When they're selected, they would be highlighted in a turquoise color, and then go to Constraints here where you see my cursor, and then you do Tangent. So now here we have made all these three curves tangential, and we're going to repeat the same process here. You can also do this by clicking on line 1 and then hold Control on your keyboard and double click the second entity, and it would also open the constraints box. So you can pick tangent here and say OK. This is a shorter process if you don't want to go all the way here. You can select this arc. It's highlighted in a turquoise color. Now hold Control on your keyboard, hover over the next entity, which shows itself in a red color, double click, and then it opens the constraints box this way too. And you can add tangent and say OK. It's the same process we did for the extrusion. We can see that we still have these disconnected edges. If you don't see them, you can go to the Accuracy Analyzer tab here and highlight check and uncheck disjoint ends so that you see them. Following this, we can use the Trim tool, keep it in the corner Trim Radio button, and select Curve and Arc. Click on the arc, hover your mouse over the next entity. You see the preview in yellow. If it looks good, click OK. So you can extend and trim and see that we have removed these disconnected edges. Now, if I show my solid, I can see that we need to make the cutout. So we need the sketch to be outside the bounds of the solid. Now, one option you can do is obviously to click and hold on this vertex, and you can drag it and position it outside like that. This is one way to do it. But if you do not want to change the direction, you can, I'm doing undo, I'm doing Control Z. Over here, we have a tool called Resize. It's very small, and it's besides the Convert Entities tool. So it's called Resize. So if you make a click on that small tool, it'll open a widget without any options called Resize. So the purpose of the Resize tool is to just extend a line or an arc without changing the direction. So here, no matter how you pull, is always going to maintain the direction of the line. So you can click and hold on that green dot and move your line outside the bounds of the solid. So here again, I have this green dot. I'm clicking and holding and moving it out of the solid. Same here, click, hold, drag it down and put it outside the bounds of the solid. So here I have this open two sketches like this. And if I want to close it, I can close it however I want. So I'm going to use the line tool. And here I'll just hover over this vertex. And when I see the coincidence icon, which is this yellow looking concentric type of an icon, click on it, move it down and drop it. And then when you hover this line over the vertex, say OK. Now here you can see that there are no disjoint ends. As you see here, there are two disjoint ends, one here and one here. You don't see them over here. So we're going to do the same process here to close out this side. Hover your mouse on top of the vertex. You see a coincidence icon. Click, single click. Now drag down. Click here. Now hover over the top of this particular point. You see the coincidence icon. Drop it. So here, right away, you get this particular sketch. It's a closed profile now. And you can add further constraints, like you can make these two arcs and you can make them equal radius. And you can provide a dimension if needed. But once this is done and you see that there are no disjoint ends and we have a closed sketch, you can come out of the sketch by clicking the exit button here, and you'll have sketch 2 in your model tree. Now, in order to make the cutout, you can go to the Model tab. So I'm clicking the Model tab where my cursor is, and here the first option is Extrude. Now, here in Extrude, I can make a click and it would ask for the base sketch. So I can hover my mouse and pick from the screen, or I can also pick from the model tree. So I can click this way, and right away it shows you a preview. So you can drag it to a point where it goes past the top face of the solid. And if you do a check mark, it is just going to make an extruded solid for you. And you can see that your solid looks like this. So in order to make a cut, you can double click on the extrude tool. So you can either right click and say edit, or you can also double click on the object to edit it. And here in result operator, instead of insert or merge, you can add cut. So if you add insert, it would add them as distinct solids. So if I add insert here, it's gonna make 3 solids for me. One would be my base solid, the second would be this solid, and the third would be this solid. So instead of that, you can do a cut option and say, okay, now this is gonna make that particular cutout for you. Then if you show your mesh, you can see that we have made that cutout pretty nicely. And at this stage, you can check your accuracy analyzer, and we can see that this side is pretty green. The area where we made the cutout is pretty green. And this is like a tool that you can continuously use as you're making progress in your model to ensure that you're modeling the body in a correct fashion. So here we made our extruded cut. I can turn off my accuracy analyzer by clicking here, and you can see that the cut is made very nicely. Now, I can hide my solid, and I can see that there is like a fillet type of a feature that runs across this particular edge like that. There's like this fillet that runs across the length of this particular body, which we do not have in our solid. So if I have my solid, we see that it's relatively flat. So in Design X, we can apply 3D fillets and 2D fillets. So I'm in the Model tab. So if you're not, please go into the Model tab, and there's this option called Fillet here. So you can click on Fillet, and you can see that we support constant fillets, variable fillets, face fillets, and full face fillets. So you can choose a particular edge or a face. So I can hover around here and click on this particular edge. And you can enter a value of a radius. You can say like make a 5 mm fillet, and it's going to make a 5 mm fillet for you there. You can make a 10 mm fillet by adding 10 here. And if you do not know the value of the fillet radius, you can always come here to the side, and there's a small magnifying glass kind of an icon that says estimate radius from mesh. So what this tool does is when you make a click on it, the software will run some calculations and it'll try to find the fillet radius from the mesh that's lying below. So it says here it's 4.7468. So you can rename or edit the value if needed to 4.75 or keep it as it is. And you can also pick the other edges that you want to fillet. So let's say you want to apply the same fillet to this edge. You can click on that edge. And let's say we want to apply it to these edges too. And you can click on those edges and you can say, okay. So when you do that, the software is going to make a fillet for you with that particular radius. Like that. So we have the fillets made here, and we have the fillet made here too. So this is how we can make fillets in Geomagic Design X. Now I can go back into the fillet tool again. So I can keep my mouse here where you see on the screen and click on fillet. And now we have an option called tangent propagation. So I can select this edge here, and if this option is turned off, and if I say estimate radius from mesh, it's gonna find the fillet value for that particular edge and leave it at that. So it came up to 4.99, so I can make it 5, and it's gonna add a 5 fillet there. Now, if I wanted to have a tangential propagation, there's this checkbox that you can check inside the options menu. And when I check it, the software will show a preview of the fillet across that whole guide. So all these edges, this whole line, it's full of tangent edges. So wherever it's maintaining that tangency, it's gonna tangentially propagate this fillet. And if you see the preview looks good, you can say OK there. So now here we have made this fillet across that whole face of the body. Then you can now click on the accuracy analyzer, and you can see that it's a pretty good fit. It's green or slightly yellow in most of the areas of that fillet. These areas look pretty green, and we are making and growing more and more accurate and closer to the actual structure of this particular body. This is how you can apply constant radius fillets and apply tangential propagation to those fillets in Geomagic Design X. Now I'm going to hide my solid again, and I can see that there are a few other structures. So we have this spherical type of an object. We have this particular cylindrical type of an object, and we have this other counterbore type of a hole. So now we saw that we extracted some vectors here. So we saw a cylindrical vector that we had extracted and a conical vector that we had extracted. We also have a spherical shape here. So for really analytical shapes, for example, we have this conical type of a hole here. You can select the area of this cone. So I'm in the Smart Selector tool. So I can click on the Smart Selector, and I can select the inside of this particular cone. So I have very easily selected the inside of that conical face. And I can go here to solid primitive. A primitive geometry is something like a sphere, a circle, a cone, etc. that I want to extract. So I can say extract a solid for me, and I can say extract a specific shape. Since I picked it before, it shows this particular points. But if not, I can put the radio button in extract specific shape, and I can select the particular faces of that conical structure. And below we have a box where it asks the shape that you want to create. So we have cylinder, cone, sphere. A torus is another name for a fillet, and a box. So here you can go to the option called cone and say preview. Now it's going to create a cone like that. And if the preview looks good, you can say OK. Otherwise, you can say restore. We have a particular option here called extend ratio. So if I extend it by, let us say, 20%, and then if I do a preview again, you'll see that the cone would be generated and it will be extended slightly larger. And if it looks good, I can say OK. So here it has made that particular cone for me. But in my mesh, it should be a cutout. So I can come here and I can say edit in the cone feature, and I can say instead of insert, make it a cut and say OK. So now here I have this particular structure cut out as a cone, and you can view your accuracy by clicking on Accuracy Analyzer, and you can see that it's pretty green. So what happened in the background was that it extracted a vector, it made a plane, and it made a sketch like this. You can find it in your model tree, and it revolved this body about that axis and made a cut. So this is very easy. Is an easy way in which we can extract primitive bodies. So to practice it, we'll hide our solid. We can go to solid primitive. We have a spherical shape here. So we can change the shape that we need to create to sphere, and we can select this particular faces. And instead of insert, we can say merge it, and then you can take a preview. And you can see that it makes a sphere for you. And when you say accept, and when you look in your solids, you can see that you have a single solid and that sphere is made. You can always check the accuracy analyzer, and you see that there is some variation here because of a fillet. So you can go to the fillet tool now and click on this edge and say estimate radius from mesh. You can click on this feature and the software will run the calculations. It came as 2.0925 mm. You can add a 2 mm fillet there and say OK. So now we have extracted that particular spherical feature. And as you can see, we are getting closer and closer to the overall structure of the body that we have made. So I can hide my heat map, and I can hide my solid, and I can see that we have to make this particular feature, this counterbore type of a hole, and this slot. So in order to do this, this is a revolved body, so I can either do it in 2 steps as 2 extrudes, or I can use the revolve tool present here. So we have already made a cylindrical vector. If you have not made that already, you can make it the following way. So you can go to the vector tool in the model tab. So I'm in the model tab here. See where my cursor is? I'm in the vector tool. And here I can choose the method, either find cylinder axis or find revolving axis. So I can choose either of these methods, and I can, it asks for some entities. So I'm using the smart selector here, and I'm selecting the faces of this particular cylinder. And you can say OK. So it would then create this cylindrical vector for you. Now you have a vector. What we are going to do is we're going to make a plane which will go through that vector. So in the plane tool, you can see in the model tab where my cursor is. Let's make a click. Now when you click here, and when you go to the methods, there are a lot of options. One is pick point and normal axis, pick point and coplanar axis. So to make a coplanar plane, you can click on pick point and coplanar axis. So here my vector 3 is already present. If it's not, you can select it and it will come here. And you can select any point. So I can come here and I can select a point like this. Now when I click a point here, it says polyvertices of one basic part, which is this point. It highlights that point and it highlights that vector. And if you see here, it shows me the preview of a plane that passes through both the vector and that particular point. So we have the vector here and we have this point here. The preview looks good, so we can say OK. So this is how you make a coplanar plane in Design X Go. And once we have made that plane, you can go into the sketch tab, and here you can go to mesh sketch. See where my cursor is? We are going to mesh sketch, and we're going to select that particular plane, plane 7 in my case, but this is coplanar plane that you created. And we can see that we have this particular feature, which is the feature that we need to create that cutout. And if you want to keep only one half, since we are going to revolve 360 degrees, you can hold this and you can move it. You can keep it if you want to, but otherwise you could just move it. So the spans, right? If you don't need this information, you could remove them and keep only the items that you need, and you can say okay. So now right here it is going to show us this particular sketch. So as you can see here, I'm going to rotate this body and hide this mesh. We have this particular shape, so I can go in my sketch palette. I'm going to the line tool, hover, double click, hover over this line, double click, hover over this line, and double click again. Now I can connect them together by doing the trim option and going into corner trim. I see this joint ends here, so I'm connecting them together. The disjoint ends are connected. I see this joint ends here, so I'm connecting them with the corner trim tool, and those are gone too. And if I want to extend this beyond my solid, I can go here. Notice this is the resize tool that we used previously, so I can click on resize, and it would bring me this widget, and I can click on this vertex and drag it up like that. And when I'm done, I can say okay. Now I can hide my solid, and if I need, I can make a center line. So you can click on this drop down you see in the line tool, and there would be something called center line here. Where you see my cursor? And you can like hover your mouse over vector 3, and you can then hover back again. You'll see a coincidence icon that looks like the icon on the screen. You can say okay. Now we see this coincidence icon, and if you want to move this particular point, you can click on this point and resize. And lastly, you can go to the line tool again and click this point and move it past the center line. Moving this past the center line. So we have this line that goes beyond the center line. Now, if I want to chop this excess section, here you can go into the trim tool, see where my cursor is. We had used corner trim for extending and connecting, but to chop off the excess sections, you can use the power trim tool, and you can hover over the excess section. So I want to remove this section, so I can click and remove it. Likewise, I want to remove it here, click and remove it, and click here again. So here we have made this counterbore type of a shape that we need to revolve. And once I've made this particular structure without any disconnected ends or vertices, I can come out of the sketch by clicking on exit. Now here I have sketch 5. I can show my solid, and what we need to do now is a revolution. So I can go here to model, and here in the create solid option, I have revolve as my second tool. So here you can click on revolve, and then it immediately asks you for a base sketch. So you can pick this sketch, and since we made a center line axis, the software automatically takes that axis. But if it did not, you can go to axis and hover over the center line, and you can say one direction or two direction and an angle of 360 degrees. And since we need a cut instead of the result operator merge, we go with cut and we say okay. So this would produce that particular counterbore feature for us, and you can show the accuracies again, and you can see that it's pretty green on the areas that we created the hole. Now we saw how we can make a revolved cut. This is a very easy way to make a revolved cut, and you can turn off your accuracy analyzer and hide your solid. We can show our mesh, and we see that there is another slot that we need to make. So in order to make that slot, we need to extrude, create a sketch and extrude it up to this particular area. If you don't want to best fit a plane there, there's another method. So you can go in the model tab, you can go and pick the plane tool. So here, if you want to create a parallel plane passing through a point, so we essentially want to create, I'm changing my cursor to the line selection mode. We want to create a plane parallel to this face, right? So in the methods, you can go to pick point and normal axis. So you can go to pick point and normal axis. You can pick this particular face. Then you can show your scan and hide your solid. Now, it needs another point. So we saw the normal axis for which we picked the face, and you click here on the mesh. You can see that the software is showing you a preview of this particular plane. It looks good, so I can say OK here, and it's made this plane 8 for me. You can rename this plane as a slot depth plane or whatever seems relevant for you, and turn on your solid. Now, till now we saw how we can use the planes that we created to make our mesh sketch, but you can also go to the sketch option. So go to the sketch tab here, and you can pick on mesh sketch. Now it asks for a base plane. You can also pick the face of a solid if it's a base plane. And you can see that right away it's also providing us with the slots shape. And you can offset if needed. So I'm offsetting it slightly down so that I get a nice shape of that particular slot. And I don't need these unwanted things. So I need only the slot, so I can shrink to where I take the trace by moving these arrows and say OK. So here I'm going to hide my mesh. I'm inside the sketch mode already, and I have the fitting tools here. So I have a tool that I can use to fit a slot directly instead of drawing a rectangle and 2 arcs. So I can click on the slot tool here, and now to make a best fit, I'm changing my selector to the line selector to the rectangular selection mode here. See where my cursor is? And then I make a drag box over the entire slot, and right away you can see that it has made this particular slot. It's applied the parallel constraints and the tangency constraints, and we have received our best fit slot. So once I have made this, I can come out of this tool, and I can now go and make my extruded cut. So I can go to the model tab, and I can say extrude. Now I can choose my sketch that I made, and in this direction I can extrude it to whatever height. And if I want to do the opposite direction, you can check on opposite direction, and here instead of blind you can use the up to surface method. So you can choose up to surface, and you can choose the slot depth plane. So it's going to cut midway like that, and choose the result operator to cut instead and say OK. So here we have a neatly cut slot up to that required depth, and you can see that it's very green and very accurate as we had intended it to be. So it's very easy to go from scan to CAD. You can progress through the portions of this model and get the work completed. So we sort of learned how to make use of the extrude features, the sketch features, extruded cut, and we also saw how we can extract vectors and make a revolved cut. We also saw how we can extract primitive shapes like cones, spheres, etc. And we'll proceed on to the following processes in the next section. Thank you.